Okay friends, let's discuss the JEE Advanced pattern questions for determinants. Let A be a 3 cross 3 matrix such that determinant of A is 4. Suppose Bij is 2i plus j aij, where I and j are varying from 1 to 3 and B is this, then determinant of B is equal to what? So what exactly is B? B matrix is, let's see what it is. The 1/1th entry of B is 2 to the power 1 plus 1 A11. So it is 2 square A11. Next similarly is 2 cube A12, 2 to the power 4 A13. Similarly the 2/1th entry is 2 to the power 2 plus 1 A21, 2 to the power 2 plus 2 A22, 2 to the power 2 plus 3 A23. And similarly you have 2 to the power 4 A31, 2 to the power 5 A32, 2 to the power 6 A33. This is your 3 cross 3 matrix B. What will be the determinant of this particular matrix? What is determinant of B? Let's compute that determinant. What would that be? Now you can see 2 square common in the first column, 2 cube common in the second column, and 2 to the power 4 common in the third column. So I can write this as 2 square, 2 cube, 2 to the power 4 common. You are left with A11, 2A21 and 2 square A31. Then here 2 cube was taken out common, so here you have A12, then you have twice of A22 and 2 square of A32. Clear? From here you took out 2 to the power 4 common, so left with A13, 2 A23 and 2 square A33. Fine. Now you can see 2 is common in the second row, 2 square is common in the third row. So you take that out common as well. This becomes 2 to the power 9. And then you take out a 2 common and a 2 square common, basically 2 cube common you take out. You will be left with A11, A12, A13. 2 has come out common, so A21, A22, A23. 2 square come out common, so A31, A32, A33, which leaves you with determinant of A. And that is given to be as 4, that is 2 square. So your answer is nothing but 2 to the power 14. And therefore, that comes out to be your very correct answer. Next question let's see is what? This determinant is equal to 0 if A, B, C are in AP, GP, HP or alpha is a root of this quadratic equation. Let's see. So over here you can very easily find out what all the operations can I apply. You can see third row is basically alpha times the first row plus the second row. So what I'll do is I'll say that row 3 goes to row 3 minus alpha times row 1 minus row 2. So when you apply this operation, you basically get what? A alpha plus B minus A alpha minus B, this gives you 0. Then you have B alpha plus C minus B alpha minus C, which again gives you 0. And here you have 0 minus alpha times A alpha plus B minus B alpha minus C. So what do you get? You get minus A alpha square, or you can just write it as this, right? So here you get minus of A alpha square plus 2B alpha plus C. Clear? Now, the first row and the second row remain the same. This is A, B, A alpha plus B, B, C, B alpha plus C. Of course, you can expand this along the third row. When you do that, what do you get? You get minus of A alpha square plus 2B alpha plus C times AC into B, AC minus B square. Or you can write this as B square minus AC into A alpha square plus 2B alpha plus C. This is the determinant, and the value of the determinant is given to be 0. This is 0 when either this is 0 or this is 0. B square minus AC is 0, that means B square is equal to AC, that means ABC are in GP, or A alpha square plus 2B alpha plus C is 0, which means alpha is the root of AX square plus 2BX plus C equals 0. So these are the two correct options in this particular question. Okay? Next question says what? If delta x is this, then talk about the value of A, B, C, D. Okay. So delta x is given to be a cubic polynomial to us basically. Now over here if I want to talk about the values of A, B, C and D, I am going to be interested in delta dash x. What would this be? 2x minus 5. Then you have 6x plus 1. I am differentiating every term on the first column. 14x minus 6. Rest two columns remain the same. This is 2x minus 5, 6x plus 1, and this is 14x minus 6. And here you have 3, 9, 21. Plus, now you are going to differentiate the second column. You have, this remains the same. What is this? X square minus 5x plus 3. Then you have 3x square plus x plus 4, and then you have 7x square minus 6x plus 9. And here you have 2, 6 and 14. And then you have 3, 9 and 21. Okay? Very easily you can see over here these two columns are same. The value of the determinant is 0. In fact, this determinant is also 0. So you are getting delta dash is actually equal to 0, which means delta is a constant. If delta is a constant, that means there is no non-zero coefficient of x cube, no non-zero coefficient of x square, no non-zero coefficient of x, only this constant term is present. That means A is 0, B is 0 and C is 0. So what is my function actually? It is equal to delta x equal D. What is D? You are going to get the value of D when you put x equals 0. If you put x equals 0 everywhere, you basically get the determinant 3, 4, 9, minus 5, 1, 6, minus 5, 1, minus 6 and 3, 9, 21. When you compute that determinant, you get the value of D, which comes out to be 141. So your very determinant or this function is delta x equals 141. That is your constant term to which my function is equal to, because ABC is going to come out to be equal to 0. Fine. Fourth question says delta AB is given to you like this, okay. Match the entries in column 1 with entries in column 2. Let's do that. Okay, so over here you can see I can perform this row operation. Row 2 goes to row 2 minus A times row 1. Row 2 goes to row 2 minus A times row 1. And I can also perform row 3 goes to row 3 minus A square times row 1. Right, so what do I get? This is 1, 5 and 10. Then this is A minus A is 0. Then this is 4A plus B minus 5A, which is B minus A. Then it is 6A plus 4B minus 10A, which is 4B minus 4A. Then you have A square minus A square will become 0. Then you have 3A square plus 2AB minus 5A square. So it becomes 2AB minus 2A square. Right? This is 3A square plus 2AB minus 5A square. So 3A square minus 5A square is minus 2A square. So 2AB minus 2A square, 2 common AB minus A square. Then here what is it that you have? You have 3A square plus 6AB plus B square minus 10A square. So this gives you B square plus 6AB minus 7A square. Why? This is 6AB plus B square plus 3A square minus 10A square, which is minus 7A square. In fact, this complete expression can be boiled down to b minus a, b plus 7a. Right? You can just see this is b square plus 7ab minus ab minus 7a square. So, b square plus 6ab minus 7a square. Same thing. I just broke the middle term, nothing else. Okay. Now, you will obviously be wanting to expand this along the first column. So, here when you do that, what you get is b minus a into b minus a whole square, b plus 7a minus 8 times, or 8a times rather, b minus a whole square. That is the value. So, b minus a whole square comes out common. You have b plus 7a minus 8a, which is again b minus a. So, you get b minus a whole cube. Clear? Therefore, over here what you have is that delta AB is coming out to be b minus a whole cube. Now, if delta AB is this, delta AB is actually b minus a whole cube, a gets matched to S. Fine. Then you have delta AB plus delta BC plus delta CA. So, delta AB is b minus a whole cube plus delta BC is c minus b whole cube plus delta CA is a minus c whole cube. Now, you know that b minus a plus c minus b plus a minus c is 0. So, this cube plus this cube plus this cube is 3 times b minus a, c minus b, a minus c. Clear? So, this expression is coming out to be equal to this. This is t. So, b gets matched to t. Okay? This is not plus, this is actually multiplication. 3 times of b minus a, c minus b, a minus c. Fine? So, what is it that you basically have is this particular term is coming out to be equal to this, that we have got thrice of b minus a into c minus b into a minus c. Now, you have limit delta x tends to 0, delta of sin x comma cos x. Delta of a comma b is b minus a whole cube. So, delta of sin x comma cos x is cos x minus sin x whole cube. And when you apply the limit x tends to 0, you know cube is a continuous function. So, this is going to become limit of x tends to 0 cos x minus limit x tends to 0 sin x whole cube. That is, limit x tends to 0 cos x is 1, limit x tends to 0 sin x is 0. So, you get 1 minus 0 whole cube, which is 1 cube, which is 1. And on the other hand, limit x tends to, if I talk about the next one, that is pi by 2, again cos x minus sin x whole cube. This is going to be limit x tends to pi by 2 cos x minus limit x tends to pi by 2 sin x whole cube, which is going to give you 0 minus 1, that is minus 1 whole cube, which is minus 1. So, you basically get C gets matched to P and D gets matched to Q. Understood? So, over here this is what we basically obtain. Now, once we have done this matrix matching thing, let us move on to the next question, which is let fx be equal to this. Okay. Statement 1, statement 2. So, I need to actually rectify these statements, verify these statements. What is this given to me? Let us try to find out. Let me say that sin x into cos x is y. Now, you need to understand why I am taking it to be y. Let us see. So, you should be aware about how to multiply two determinants. You have 0 cos x minus sin x 0 cos x, and you have cos x sin x 0, right. After this, multiplied by the same determinant 0 cos x minus sin x, then you have sin x 0 cos x, and then you have cos x sin x and 0. Okay, this is what is your fx. How do you multiply two determinants? Let's see. So you have 0 into 0 plus cos x into cos x, cos square x plus sin square x. Cos square x plus sin square x is 1. Then you have second row being multiplied with the first row. So sin x into 0, 0 plus 0 into cos x, 0 minus sin x into cos x, that is minus y. Then you have cos x into 0, 0, sin x into cos x is y, this is 0, so you have y. Clear? After this you have everything being multiplied with the second row. So 0 into sin x, 0, cos x into 0, 0, minus sin x cos x, that is again minus y. Then sin x into sin x, sin square x plus cos square x, that is 1. Fine. And then you have this being multiplied with the second row. So y plus 0, so that is y. After this you have everything being multiplied with the third row. So 0 cos x into sin x, y. So here you have a y. After the second row being multiplied with the third row, so sin x into cos x plus 0, so you have again y, and then you have cos square x plus sin square x is 1. Now over here you can very easily see I can subtract these two columns. I can say column 1 goes to column 1 minus column 2. So if I apply that, what is it that I get? Or yeah, so column 1 minus column 2. So 1 minus y makes it 1 plus y. And minus y minus 1 is minus of 1 plus y, and you have y minus y is 0. Then I can talk about adding these two columns. Column 2 goes to column 2 plus column 3. So minus y plus y gives me 0, 1 plus y is what I have over here, and again y plus 1, which is 1 plus y. This is y, 1. You can see 1 plus y is coming out common from the first column and the second column. So you have 1 plus y whole square 1, 1, 0, 0, 1, 1, y, 1. Fine. So you basically, if you expand along say this first row, so you get 1 plus y whole square into 1 minus y. So this is 1 minus y, 1 minus 0. So you get 1 minus 2y. This is your very f of x. Statement 1 says that if sin 2x is 1, then fx is 2 by 3. Okay. Now sin 2x is 1. Let's see. If sin 2x is 1, then fx is 2 by 3. True or false? So sin 2x is 1 means 2 sin x cos x is 1. So sin x into cos x, that is y, is 1 by 2. When y comes out to be 1 by 2, this expression becomes 0. 0 into anything is 0, so fx is 0. And so obviously this is false. If sin x is equal to cos x, okay, so sin x is equal to cos x, so what is y? What is y? Sin square x. Y is sin square x, so 2y is 2 sin square x. 1 minus 2y is 1 minus 2 sin square x, which is cos 2x. Cos 2x is cos square x minus sin square x, but cos x is same as sin x, so this is 0. So what I said is if y is equal to, so this was y was equal to sin square x, 2y was 2 sin square x, 1 minus 2y was 1 minus 2 sin square x, which is cos 2x, and cos 2x is coming out to be 0. 0 into anything is 0, so fx again is 0. So this implies fx is also 0. Clear? And therefore this is true. So statement 2 is true and statement 1 is false. This statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is true, so B is correct. And 1 is not giving any correct, forwarding to the statement 2. So here after this question, let's move on to the next. You have A, B, C, coordinates are given to us. Let they be 3 points. Area of triangle with vertices ABC is given by this. So this is something that we already know, but the question is giving us that information as well. Now we have questions, 3 questions which are following this particular observation. Point A, B, C are collinear if and only if. What is among them true? Very clearly, if this is the area of the triangle with 3 vertices, those 3 vertices as points, if they are collinear, there will be no triangle formed and the area of that triangle will have to be 0. This is a but obvious thing. Next, if A is BC, B is CA, C is AB and 2S is A plus B plus C, okay, then delta square is equal to what? Now see, over here we have already done this in trigonometry chapter also, in solutions of triangle, that by using the Heron's formula, when you are aware about the sides of the triangle, you are very much aware about the area of the triangle in terms of the sides, which is under root S, S minus A, S minus B, S minus C. Area is given by delta, so delta square is going to be removal of the under root, just S, S minus A, S minus B, S minus C. So we've already done this. Next question is, if triangle ABC is an equilateral triangle and A equals BC is a rational number, then the area must be what? So when you know that when triangle is equilateral triangle, then your area is root 3 by 4 A square. A is given to be rational, so A square is rational, 4 is rational, but root 3 is irrational. So root 3 by 4 A square will be very clearly irrational. Fine. Next, let's see what we have next. Here we have let fx be equals to 2 cos square x sin 2x minus sin x. This determinant is given to us. Then 1 by pi 0 to pi by 2 integral of fx plus f dash x is equal to what? Now over here, if I say column 1 goes to column 1 minus twice of sin x column 3, what do I get? Column 1 goes to column 1 minus twice of sin x column 3. That means this is 2 cos square x already. This is going to become 2 sin square x, right? So 2 cos square x plus 2 sin square x is what it is going to become, isn't it? So what I'm trying to say is this is 2 cos square x minus is going to become plus 2 sin square x. So 2 common, cos square x plus sin square x is 1, 1 into 2 is 2. Similarly, sin 2x minus 2 sin x cos x. Sin 2x minus 2 sin x cos x is sin 2x minus sin 2x, which is 0. Then you have sin x, this becomes sin x only because here you have 0. Similarly, I am saying column 2 goes to column 2 plus 2 cos x column 3. So let's see, sin 2x minus 2 sin x cos x, which is what? 0 again because this sin 2x minus sin 2x. Then you have 2 sin square x plus 2 cos square x. So 2 common, sin square x plus cos square x is 1, this is 2, and here you get the same minus cos x. So here you have minus sin x, cos x and 0. Expand this along any row. What you get is this is 2, this is 0 plus cos square x minus sin x, this is 0 minus 2 sin x. So you basically get 2 cos square x plus 2 sin square x, so this is just equal to 2. So your fx is coming out. Your fx is coming out to be equal to 2. If fx is coming out to be equal to 2, very clearly what is f dash x? If fx is 2, f dash x is 0. So 1 by pi integral 0 to pi by 2 fx plus f dash x is just this. Fx is 2, f dash x is 0. This gives you what? 1 by pi into 2 into pi by 2. Okay, so after this, let's move on to the next question. We have this determinant to be given as very function fx. We are asked to compute the maximum value of fx. Let's see. Okay, so this is your fx. Let's try to apply operations to simplify our fx. I can say, if I say column 1 goes to column 1 plus column 2, fx becomes what? 1 plus sine square x plus cos square x, that is 1 plus 1 which makes it 2. Then you have sine square x plus 1 plus cos square x which is again 2, and sine square x plus cos square x gives you 1. Rest you have the same cos square x, 1 plus cos square x and cos square x. Then you have 4 sine 2x, 4 sine 2x again, and 1 plus 4 sine 2x. So now what you do, you can very easily see these two are same and these two are same. So you can apply two operations, rho 2 goes to rho 2 minus rho 1 and rho 3 goes to rho 3 minus rho 1. Fine. So what are you going to get from here is basically 2 cos square x, 4 sine 2x, this is as it is, 2 minus 2 gives you 0, 1 plus cos square x minus cos square x gives you 1, and this minus this gives you 0 again. Then 1 minus 2 gives you minus 1, cos square x minus cos square x gives you 0, 1 plus 4 sine 2x minus 4 sine 2x gives you 1. When you open this up, what is it that you get? Let's open this up along this particular row itself. So you get twice of 1 minus 0, that is 1, minus cos square x. Minus cos square x, you get 0 minus 0, this is 0, plus 4 sine 2x. This is 0 plus 1, that is 1. So you get 2 plus 4 sine 2x. This is my very fx. Now it's very easy. Maximum value of sine 2x is 1. So maximum value of 4 sine 2x is 4. So maximum value of 2 plus 4 sine 2x is 2 plus 4, which is 6. So maximum value of fx comes out to be the integer 6. Clear? That's how you deal with the questions. That's it from my side. Thank you.